Alright, so in this video I'm going to go over graphing quadratic functions in each of the three forms. So the first six are in vertex form, even though the first one could also be considered standard form, where the x term is 0, the b value is 0. But it doesn't matter, it will get the same answer either way. For number 1, like I said, first thing we're going to do is find the vertex, and remember the vertex is hk. Since there is nothing added after the x, h is 0 and then k is negative 4. So 0, negative 4. This quadratic, the parabola, is concave up because the a value is positive. So for that reason we have a minimum value, and the minimum value is the y value of the vertex. So this is negative 4. The domain is all real numbers, and the range, because again it concaves up, the range is from negative 4 to infinity. Okay, the y-intercept, this is the c value, the constant, so the y-intercept is negative 4. So we write 0, negative 4. To get the x-intercept, you replace the f of x, make it 0, so I'll show the work right here. So 0 equals x squared minus 4, and then you solve for x. So we add 4 to both sides, and then we take the square root of both sides, so then that leads you to plus or minus 2 equals x. So those are your two x-intercepts. So you could write it together like this, plus or minus 2 comma 0. That's fine. You don't have to write them separately. So now we're going to graph this. Okay, so let's see. Use that color. And the vertex is 0, negative 4. The x-intercepts are 2, 0, and negative 2, 0. And you could, if you want to plug in another number, that's fine. So like, let's say if x is 3, that would be 9. X squared is 9. 9 minus 4 is 5. So right here, 4 at 3, 5 would be another point. And because the parabolas are symmetric with respect to the axis of symmetry, we know that we have negative 3, 5 as another point on the parabola. Okay, and connect. Remember, it's not a V shape, so make it, it's hard to control this pen, see, it's all crooked, but it's a curve. Try to go over it. It's a curve, not a V shape, okay? So there's the first one. Alright, for number 2, H is positive 2 and K is negative 3. And that's your vertex. So 2, negative 3. This quadratic also, the parabola also concaves up. So we know we have a minimum value, and the minimum value is the y value of the vertex. This leads us to the range. The range goes from negative 3 to infinity. And then the domain, of course, is all reals. If you want the y-intercept, you make the x value equal to 0. So we're actually looking for f of 0, which is 0 minus 2 squared minus 3. And so 0 minus 2 is negative 2. You square it, you get 4. 4 minus 3, that's 1. So the y-intercept is 0, 1. For the x-intercept, we make the f of x, the y equals 0. So this would be 0 equals x minus 2 squared minus 3. So we add 3 to both sides. So that'll give us 3 equals the quantity of x minus 2 squared. Okay, I'm going to take the square root of both sides. I'm going to move the work over here because I ran out of room. So that gives you plus or minus the square root of 3 equals x minus 2, because I took the square root of both sides. I did this. Okay? I'm going to add the 3. So, the 2. So then I have plus or minus radical 3 plus 2 equals x. So that's my x-intercept. So you could write it like I did on number 1. You could write it as a single point. As a single ordered pair, but I know it's not. It's two of them because of the plus or minus. So usually we put the constant in the number without the radical in the front, plus or minus radical 3 like that, comma 0. So this represents both x-intercepts. Okay, if you want the approximation, just put this number into the calculator. So you would do 2 plus radical 3, and then 2 minus radical 3, and then you would plot those points. Okay, so let's go ahead and plot this graph. So we have the vertex is 2, negative 3. And then we have the y-intercept 0, 1. Now remember, if 0, 1 is on the graph, you know that on the other side of the vertex, there's also going to be a value at 1, right? Because it's symmetric. The parabola is symmetric. So at 4, 1, there's another point right there. Okay? And that's basically all you need for graphing the parabola, the 3 points. So you go like this. Oops, missed it a little bit. So there's your parabola for number 2. Alright, number 3, again, another function in vertex form. The h value is negative 1 because this is a plus 1, so that means that that h has to be negative 1, because the formula is x minus h. So if this is plus, that means h is negative 1, and k is positive 2. So that's your vertex, negative 1, positive 2. Okay, it concaves up. When you graph it, the parabola concaves up, so that means it has a minimum value, which equals the y value of the vertex, so that's 2. The range goes from 2 to infinity, and the domain is all reals. The y-intercept, we replace the x with a 0, so we get 2 times 0 plus 1 squared plus 2. So 0 plus 1 is 1, 1 squared is 1. 1 times 2 is 2, 2 plus 2 is 4. So the y-intercept is 0, 4. Okay, and then we have the x-intercepts. So we replace the f of x with 0 and solve for x. So we write this here. Okay, now what's going to happen is when you move the 2 over to this side, it's going to be negative. So you're going to have a negative 2 equals a 2 times the quantity of x plus 1. And then remember, you're going to divide by 2 to isolate the parentheses. But then when you take the square root, you're going to have a negative number. And that's not a real number. That's imaginary. So there are no x-intercepts because you get an imaginary number. So there are none. Another way we could have seen this even before doing the work is to recognize that the vertex is at negative 1, 2, and the parabola is concave up. So it's not ever going to cross the x-axis because it's going up. Okay, so this is the like mathematical reason why. But then you could also use common sense and realize that, okay, this is a vertex, it concaves up because A is positive, it's never going to touch the x-axis. Okay, so that's another way. So let's go ahead and finish plotting this. We have 0, 4 as your y-intercept. And if 0, 4 is a point on the graph, then we know that negative 2, 4 is also a point on the graph because parabolas are symmetric. Okay, so there you have it. Make it concave up, and there's your parabola. For number 4, go back. The h value is positive 1. and the k value is positive 4. This negative right here tells me that it concaves down. Okay, so it's going to be 1, 4. Since it concaves down, it has a maximum value, and the value is 4. The domain is all reals. The range is from negative infinity to 4. Okay, because it's the parabola is concave down. The y-intercept, remember we replace the x with a 0 and then solve for y. So negative 1 squared is 1, but then there's a negative right here in the front, right here, this one, so it's negative 1 plus 4, that's 3. So 0, 3 is the y-intercept. The x-intercept, replace the f of x with a 0, so that's 0 equals negative. Now at first glance you might think, oh, it's the same as number 3, because when I move the 4 over I end up with a negative 4, right? But remember, notice the a value is negative, so I'm going to divide by negative 1 first, so this becomes positive, positive, right there. And then, so now I can take the square root of both sides, and so I end up with plus or minus 2 equals x minus 1. So now I add 1 to both sides. So I get 1 plus or minus 2 equals x. So the two values of x is 1 plus 2, which is 3, and 1 minus 2, which is negative 1. So those are my x-intercepts. So now we're going to plot this. The vertex is 1, 4. The x-intercepts are 3, 0, and negative 1, 0. And then I have a y-intercept of 0, 3. Since I have a 0, 3, then I know that I have a 2, 3 because of symmetry. Okay, and then so connect your points, and there's your graph.